Now, one of the reasons we look at the periodic table so much in chemistry is it gives us a lot of information. For example, it can tell us what kind of reaction is possible between two elements. The first type of reaction we're going to look at involves the formation of ions. An ion is an atom that has a net positive charge or a net negative charge. All atoms start off neutral. In other words, a particular atom will have a certain number of protons. For example, fluorine is atomic number 9. We can find that on the periodic table. So every atom that contains 9 protons must be called a fluorine atom. If it's neutral, we know it also has 9 negative charges. So the only other particle in an atom that has a charge is an electron. So a fluorine atom that's neutral will have 9 positive protons and it will have 9 negative electrons. That makes it neutral. However, during the course of a chemical reaction, that can change, and the fluorine could turn into an ion. Whether it's going to be a positive ion or a negative ion, we can get that information from the periodic table. The tendencies of metals and nonmetals are opposite each other. Metals have a tendency to lose electrons. If a metal loses 1 electron or 2 electrons or 3 electrons, that means that the number of protons it has will be greater than the number of electrons it has. And if you have more positive charges than negative charges, that's going to be a net positive ion, which we call a cation. Nonmetals are the opposite. Instead of losing, they tend to gain electrons. When it gains electrons, now the number of protons that it has, remember that identifies what type of element it is, so we cannot change the number of protons. We can gain or we can lose electrons, but you can't change the number of protons. So when a nonmetal gains electrons, now the number of electrons is greater, so it has a net negative charge, which is called an anion. This is one of the topics that we're going to come back to again and again and again in later chapters. Now we're going to take that one step further and figure out how many electrons are either going to be gained or going to be lost. And the key again is on the periodic table. So if we're talking about a main group metal, remember that's the first 2 columns, 1 and 2, and then the last 6 columns, 13 through 18. So if a metal is found there on the periodic table, it's usually going to lose the same number of electrons as the last digit of its group number. Which you find on the periodic table. So this is a lot easier to see with an example. So sodium, remember capital N, lowercase a. When you find sodium on the periodic table, you'll see that it's in group number 1. The last digit of 1 is 1. So a sodium will lose 1 electron. The number of electrons it started with was equal to the number of protons, because remember it starts off neutral. So a sodium atom that's neutral, we can look up its atomic number on the periodic table and find that it's number 11. So it has 11 protons and 11 electrons. If it loses 1 electron, 11 electrons are going to change to just 10 electrons. It still has 11 protons. Now it lost one electron, so we write that as a sodium with a superscript and a plus sign to show that it's a +1 cation. Magnesium is right next to sodium on the periodic table. Capital M, lowercase g. It's in group number 2. A sodium lost 1 electron. A magnesium, being in group 2, is going to lose 2 electrons. So magnesium started off with 12 protons and 12 electrons because it started neutral. If it loses 2 electrons, that number drops down to 10. So now magnesium has 2 more positives than it does the negatives. 12 positive protons, 10 negative electrons gives us a net charge of +2, which we write as a superscript. And notice the number comes first and then the positive sign. Also notice with the sodium we did not put the number 1. It's understood if you just see a positive sign, that means +1 charge. Aluminum is also a main group metal. It's in group number 13. So the rule is take the last digit of the group number, which is 3. So our aluminum that started with 13 protons and 13 electrons, when it forms an ion, it's going to do so by losing 3 electrons. So instead of 13, it'll only have 10, which means aluminum will have a net +3 charge. If you notice the pattern that we've been going through, the shortcut, we don't have to write down how many protons and how many electrons we started with. All we have to find is the last digit of the group number. Sodium was in group 1, it makes a +1 cation. Magnesium is in group 2, it makes a +2 cation. And aluminum, being in group 13, last digit is 3, it made a +3 cation. So the key thing to remember is if you're talking about a main group metal, it will make a cation that has the same charge as whatever the last digit of the group number is.